Okay, these are the notes for 12.5, areas and volumes of similar solids. Similar solids are solids that have the same shape but not necessarily the same size, and everything is in proportion. Okay, so some examples are down here, and we've dealt with these a little bit before in two-dimensional shapes. So what I'd like you to do first is, for the figures, find the scale factor, ratio of the base perimeters, ratio of the lateral area, and the ratio of the volumes for each figure. Make sure you reduce them, and I want you to look for some relationships. Maybe see something here, and then as you make your calculations here, see if it holds true, and come up with some conjectures of what you might believe we are trying to see, what kind of relationships we're trying to see. So please push pause now and work through those. All right, as we come back, these are the answers that you should have. Okay, again, I showed the numbers and then in reduced form to the right. Okay, and I'm hoping you're seeing some relationship between the scale factor and the base perimeters ratio, the scale factor and the ratio of the lateral areas, and the scale factor and the ratio of the volumes. Using that, I would like you to fill in these 3 blanks. So push pause, fill in the blanks, and then we'll check back. All right. So you should have saw that the ratio of the corresponding perimeters is still A to B. We went over that in chapter 7. This is actually the 3rd time we are kind of studying that idea. The ratio of the base areas, lateral areas, total areas is A squared to B squared, follows from a similar relationship we saw in chapter 11. And now the new idea, the ratio of the volumes, is A cubed to B cubed. I put a note down here. I know the top seems like a very basic idea. Of course, the ratio of the volumes is volume to volume. You need to remember what a proportion is fundamentally. It's saying that this ratio is the same as the ratio on the other side, that they're equal, that they're talking about exactly the same thing in the same order from top to bottom. What happens is you tend to have like a ratio of areas and you might use it to solve for heights. That's not the right thing. So be very careful, very cognizant of looking what does the left side represent of your proportion and then what does the right side, and make sure they're representing the same thing. So here are 4 questions for, again, you to answer. So think through these and push pause, try to give your answer to these. All right, coming back. Are all spheres similar? Yes. There's the radii measurement. They're always going to be in proportion. Right cylinders similar? No. You could have one ratio exist between the 2 radii and a different ratio between the heights. So not all right cylinders are similar. Are cubes similar? Yes, they are. They all the lengths will be the same, so whatever the lengths are, they'll have to be the same ratio. And respectively just means that the 8 and the 16, the 12 and the 24 go together. And if you check the ratios on those, they reduce to the same thing, to 1 to 2, so they are similar. All right, again, in the next one, I would like you to push pause and do your best to work through these yourself. When you're done, come back and check the answers. So please push pause now. All right, as I go through the answers here, I notice that this is the base area. So that's my A squared to B squared ratio. I reduced that down to a 1 to 9. And then to find the A to B ratio, I made it 1 to 3 by square rooting both sides. Okay, so I square rooted, and the ratio of the heights is going to be the same as the scale factor, so that's 1 to 3. If the height of the larger pyramid is 27, okay, I'm going to be comparing heights, so I need to make sure that that goes with the right ratio over here. So heights goes with scale factor, so it's a 1 to 3. When you solve the proportion, you get 9. Over here, oh, I didn't finish this one. I apologize. Volumes is 27 to 64. So that means my A cubed to B cubed ratio is 27 to 64. If I cube root each of those, I get 3 to 4. But again, look, I'm looking for the area of the smaller sphere. So if I'm looking for area, I got to now go back to the A squared to B squared ratio. So I'll square them both, and I get 9 to 4. Or I'm sorry, 9 to 16. So working from that idea, 9 over 16 equals, okay, I was given the area of the smaller sphere. That should be on the same level as the smaller number in the ratio. And when you solve that, you should have gotten 32 as your answer. All right, one more set of questions. So please try these again on your own and then come back and check your answer. So please push pause now. All right, so the first thing I did is I again identified this is the ratio of the areas. So I said that's a squared to b squared. That's kind of your basis. And then I square rooted to find the a to b. So that's the ratio of the radii. The heights is going to be the same as that, 2 to 3. For the total area ratio, I'm going to square the scale factor. So that got me to 4 to 9. And for the ratio of the volumes, I'm going to take that original scale factor and I'm going to cube it. So that's 8 to 27. For the volumes, it gave me 2 volumes. That means that's my a cubed to b cubed ratio. And I'm going to cube root both to get back to it 5 to 4. And then I check, what am I looking for? Base perimeters. Ratio of base perimeters is the same as the scale factor, so the answer there is 5 to 4. All right. The homework assignment is on the calendar, on the Canvas calendar. So please try the homework assignment and use your notes to help you.